Consider the following data for a dependent variable y and two independent variables x1 and x2. And before I start analyzing these data, I'm going to take a quick graphical look at the data set. And one nice way of doing this is to use a matrix plot. So this is the matrix plot that Minitab comes up with, often called a scatter plot matrix. And this allows me to see all the data at once with all the variables. And one reason for taking a graphical look at the data here is to see if there's any points that stand out in an extreme way. They look very different to the others, perhaps because I've made a mistake in entering my data and I need to correct that before continuing. So that's the kind of thing we're looking for in this graphical look at the data. Anyway, there's nothing too alarming about this plot, so I'm going to proceed with my analysis. And first I'm going to develop an estimated regression equation relating y to x1. So I'm going to use Minitab again to get the estimates for this equation. And then next I'm going to predict y if x1 equals 45. So all I need to do is plug in x1 equal 45 into that equation, and I obtain y hat equal 132.6. Next I'm going to do the same thing but with x2 instead of x1. So this is the equation that Minitab gives me, and this time I'm going to predict y if x2 equals 15. So plugging in x2 equals 15 into that equation, I obtain 150 for y hat. And then finally I'm going to develop an estimated regression equation relating y to x1 and x2. So this is the equation that Minitab gives me. And one thing to notice is that the parameter estimates in front of each of the independent variables, so 2.01 in front of x1 and 4.738 in front of x2, those are different to the parameter estimates in front of the corresponding independent variables in the single independent variable equations. So in front of x1 I had 1.944 in the first equation we derived, and that differs to the 2.010 in the equation, in the two variable equation we just obtained. And similarly 4.32 in front of x2 in the second equation that we obtained, that differs from the 4.738 in front of x2 in the last equation we obtained. The only times when those numbers would be the same would be if the sample correlation between x1 and x2 was exactly 0, and that's not the case here, and it's seldom the case. It's really only the case in specially designed experiments where x1 and x2 are designed to have a 0 correlation. But as in most observational studies, the correlation is not exactly 0, and so these parameter estimates differ. And finally, I'm asked to predict y if x1 equals 45 and x2 equals 15. And so if I plug in the values 15 and 45 into my equation, I obtain y hat equals 143.1.